I am really excited to be here, and I hope that you are as well. So the first thing I wanted to say is you're probably wondering, why am I here? I'm not somebody that's probably known to most of you, and I do have a variety of different types of education. Basically, I'm a jack of all trades, and I'm a master of none. So I've practiced in veterinary medicine. I've got a PhD in microbiology. I have a very, very strong interest in drug resistance. I first experienced it as a surgeon treating surgical site infections in dogs and cats. And I'm now periodically treating them in swine in a research setting. And I just happen to be lucky enough to be involved in a research group that did a really interesting study in the last couple of years. And so I feel extremely fortunate, and I want to thank the organizers of the meeting for inviting me to be here and share with you a little bit about what we found in our research. So the objectives today, first of all, are for me to make sure that neither you or I become overwhelmed with the topic. As a scientist and as a veterinarian, and after doing this project, I have to tell you that I feel like this is one of the biggest and most complex topics that I've ever tried to study in the course of my career. And it is super easy for me to sit down at night and wonder if I'm going to be able to go to sleep for concern over understanding even a small portion of the problem. The result of that is that it's really easy to become paralyzed and really fearful about, can we do anything that's going to be really meaningful about the problem? And I think that we can. I fully believe that there's hope for the future, and keep that in mind. I'm going to try to really bring some specific items that we've learned to the forefront, and there are all kinds of other things that you guys know, but I think together we can make some progress. I'd like to review some specific things that I found particularly interesting from our recent study, and hope that those things will be meaningful to you as well. And I'd also like to suggest some opportunities for improvements that we learned during the course of our research, and some struggles that we had comparing literature that's published and that we were trying to review. The first thing I'd like to do is some disclosures. I'm actually, rather than Virginia, I used to be a veterinarian at Virginia Tech, but I'm currently with the VA. And so the first thing I have to say is that my topic and my talk here today does not represent in any way the thoughts of the federal government, nor of the Veterans Administration. So this is all me and my colleagues, and the team is so important to have multidisciplinary teams that I didn't feel like I could present this today without sharing with you who my team members were. On the Campylobacter project, I was the primary author, and the other team members involved were Christy Helke, who's a veterinary pathologist, Ashley Galloway, who's a dietitian and runs the dietetic services at the College of Charleston in Charleston, South Carolina. Ann Poole is an educational specialist. Cassie Salgado is actually the director of hospital infection control at the Medical University of South Carolina, and an expert in infectious disease for humans. She's an MD. And Bernadette Marriott, who is our senior author and the person who really ran our project for us, as our leader, is a lifelong nutrition researcher with a background in biochemistry. And she's even done studies in the wild of capuchin monkeys and their feeding behaviors and nutrition related to monkeys. We were funded, great thanks to the Animal Health Institute, when we started the project. And then the project was big enough, as I said, it's really complex, that it continued well beyond that funding period. And so we do need to acknowledge also the Medical University of South Carolina and the VA for providing resources for us to complete the work and bring it to the point where both a Campylobacter study and a side-by-side one with Salmonella have now been published in the critical reviews in food science and nutrition. At the beginning of the study, we all did incorporate a bias study and a discussion about what we were coming to the table with in terms of pre-existing ideas about the problem, because we very much as a team wanted to come up with an objective and as unbiased as possible review of the literature that we were going to be looking at, and wanted to bring some real scientific integrity to viewing this information. As all of you, I'm sure, are aware, there are things in the published literature that obviously have opinion that drive some of the conclusions that are there. So you can hold my feet to the fire about that. None of us own any stock or have any financial interest in any companies that in any way would influence what we did. So the background for the project was that it was really initiated after the 2013 CDC report came out on the antibiotic resistance threats. And first of all, let me put this in perspective, because I know I lost it several times during the project itself. This report by the CDC says antibiotic resistance threats. So in the context of foodborne illness, remember there are lots of things besides bacteria that cause foodborne illness. In fact, norovirus causes much more GI illness than Campylobacter. Okay, so we're not trying to say that Campylobacter and Salmonella, the two things that we studied in depth, are the primary problems, but in the context of antibiotic resistance, these are the problems we're focused on. Okay, so our task was trying to look at the question, what published literature evidence actually exists to determine if there is a direct link between the use of antibiotics in agricultural animals that are being produced for food for people, and is that there a clear connection between that antibiotic use and an increase or apparent increase in the prevalence of antibiotic-resistant infections in humans, specifically related to foodborne illness, and in my project, specifically with Campylobacter. So for Campylobacter in the life cycle, we were really focused on a couple of different areas here. This is a really nice illustration that came from Nature Reviews, Microbiology. We were not looking at the entire life cycle, so kind of a disclaimer from the beginning. Part of what we do in research is we have to find things to focus on, because if we're too broad, we never get anything done, quite frankly. So we were very interested in the connections between the farm and the fork. So the areas we looked at here in this life cycle were between the cows on the farm, what were the products that came from them, for instance, and then ultimately, was there a link with people? Same thing with poultry or swine. We looked at a lot of different animal species. What we really did not look at, and we actually had specific exclusion criteria, sorry about that, was we really didn't look at the environment and were organisms in the environment directly transmitted to people. We didn't look at domestic pets and direct contact with them. We didn't look at petting zoos or other activities like you might see at a fair. We excluded travelers' diarrhea, and that's actually one of the ways that we see a lot of drug-resistant Campylobacter infections is people coming back from foreign travel. And they get home and they're sick, and they've actually brought the organism here to our country from elsewhere. So we couldn't look at all those things in the context of this project. So what we're talking about today is really specifically looking at domestic farm animals, no wildlife, none of these other animals that we know they have something to do with the overall problem. They're a piece of the puzzle, and we're just focusing on a couple of those. So what does it mean to do a systematic literature review? This was my first experience with one, and you actually have to be very careful about how you select and move through the process. Suffice it to say for now that we started with a list of predetermined words that were keywords that drove our search strategies, and that we determined what kind of databases we were going to search from. And what you end up with is initially tens of thousands of documents and papers, and you continue to add words to the search string until you can get the number of articles down to a reasonable number that you can evaluate and put your eyes and hands on each one of those articles in the end. The details of this are listed actually in the published material, so you're welcome to read more about those details. What I wanted to share with you today is some of the findings, again, that I felt were really interesting to me and that I thought would be interesting to you. The way that I selected the items that I'm going to tell you about is Couple of strategies. One was, as part of our systematic review, we graded the different articles that we reviewed. In other words, we tried to determine as objectively as possible through a scoring system which articles had subjected themselves to the most scientific rigor. So I've selected a couple of the articles that I felt were what were the best representations of science put into the agricultural setting. And then specifically a couple of the antibiotics that we know are medically important ones and how the findings are useful in that arena. So first of all, one thing I thought you'd be interested in is this project that was done on growing turkeys. And this was a very large study. There were 30,000 birds total, 15,000 birds in a control group, and 15,000 that were getting treatments with Tylosin in the drinking water. The treatments were given according to FDA-approved labeling on the medication. What they found in this study was that there was an increased prevalence of macrolide resistance in the birds immediately after the treatments were given, and then it would drop off when the antibiotic was removed from the water of the birds. Interestingly to me, because I'm not somebody who's ever been involved in the actual production of food in terms of the slaughterhouse and the production facilities, is that the detection of the organisms post-chill was very low. And I'm going to show you a graph from this actual paper. So you can see where the high or the very tall gray bars are showing the percent of organisms that were recovered that showed resistance to erythromycin. And the interesting thing to me is the gray bars get really tall after the treatment, and so we do see that the animals become more colonized with bacteria that are resistant to antibiotics. However, in this particular situation with the macrolides, you can see where after the treatments have stopped, the baseline or the background of the percentage of resistant organisms falls. And then if you go to the post-chill samples that were reported in this. Sorry, I'm having a hard time getting the slides to advance. I'm not sure what I'm supposed to be pointing this at. There we go. This very last sample, which should be to your right with the P, is for post-chill. And so you can see as high as the antibiotic resistance that was detected in fecal samples on the farm, that was dropped dramatically at the post-chill step. So in this particular situation with the Tylosin, it was helpful to remove the antibiotics from the environment and certainly from the water of the birds. That's very different from fluoroquinolones. What we learned about fluoroquinolones is that in studies with fluoroquinolones, once the resistance is gained by the organism, it doesn't want to let it go. And one of the ways that I think about this is that if you think about having tools, say you're on the Survivor show, you're more likely to make it through the show and perform really well if you have plenty of tools for the environment that you're living in. But it takes energy to carry the tools around all the time. So unless you need to use the tools, you probably don't want to carry them and use your calories for carrying the tools around. So what these bacteria do is they carry their tools or their ability to live in the presence of antibiotics when it's beneficial for them to do it. In the case of the macrolide resistance, these organisms that have the tool to live in the presence of antibiotics find that it takes a lot of energy to do that. And so once the antibiotics are removed, they're like, whew, thank goodness, I can put the tools down, I am done, I'm going back to my original way of living. The fluoroquinolones, for whatever reason, once they develop that ability to be resistant, those tools don't seem to use up extra energy for them. So they just continue to carry them around. And even when we take the antibiotics away, the resistance is maintained. So that is a great example of showing that there's not a simple answer in terms of just removing antibiotics from animals. It's not necessarily going to make resistance disappear. That there's not going to be any magic solution like that. In pigs, we looked at a couple of articles that I thought were quite well done, looking at, and this is a big question in a lot of people's minds, What's the difference if you raise animals in a conventional, which means in the presence of antibiotics, versus an antibiotic-free environment? And the big picture result of that, at least in swine, was that the prevalence of Campylobacter in the animals on the farms, and this is typically from fecal samples, is really not different. What you see that's different is the percentage of those organisms that are resistant to antibiotics is higher on the conventional farms in the presence of the use of antibiotics. One of the papers that we looked at different life stages of the pigs. So they went from farrowing, nursery, finishing pigs, and they looked at several different classes of antibiotics. They looked at tetracyclines, at macrolides, and at fluoroquinolones. And in each of those different stages of life, they were able to show that when the antibiotics were present in the feed, that there was an increased prevalence of drug-resistant organisms. However, there's another caveat, right? The post-chill step in pork seems to be outstanding at getting rid of organisms in general. In fact, Campylobacter is found at such low rates in commercial pork and beef that the NARM system doesn't even monitor for Campylobacter in those food products anymore because the rates are so low. So on the one hand, yes, we know that the animals are colonized more heavily with drug-resistant Campylobacter in the presence of antibiotics. What is the long-term consequence of that in terms of what makes it to the consumer? Well, for beef and pork, there may not actually be as big a problem as sometimes people would like to think. That also doesn't mean that having animals that are highly colonized with drug-resistant bacteria is a good thing. I'm not saying good or bad, I'm just saying what are the practical implications. So what did we find in humans? Those were a couple of things I thought from the animal side of our project you'd be interested in. Now on the human side, we were able to find one paper only, and so this is not saying that the CDC doesn't have information that's more detailed than what we looked at. But for the articles that we were able to find, there was one that showed direct transmission of an antibiotic-resistant Campylobacter from an animal product to humans. And it was this Campylobacter jejuni, clone SA, which stands for sheep abortion, and it's a specific strain of Campylobacter. And it was identified as being the cause of zoonotic disease in people. The milk came from a farm in Pennsylvania, and it was raw milk. And I think that's very frustrating to me. I assume it's frustrating to you that the agriculture community might get blamed for people getting foodborne illness when they eat food or food products that we know could be safer. And unfortunately, part of life, and we all know this from the current national elections, people make a lot of decisions based on emotion. Not necessarily on facts, not necessarily because they're trying to be rational. And I think this picture of the I drink raw milk, arrest me is a perfect example of that. Is that some of the folks that drink raw milk are very, very emotional about that. They're very in tune to this is what I think is most healthy for me, even if it means their kids get Campylobacter from it. They'll go back and use raw milk again, sometimes even when we educate them that pasteurization makes it safe and doesn't remove the nutritional value of the milk. So a big challenge. In this paper, another thing we found challenging was that there was no information about antibiotic use on the farm. So there was no way for us to look at that paper and say, sure, here's the transmission to the humans. We know they got sick from this genetically confirmed isolate of the bacterium. Well, we don't know. Did that farm even use antibiotics? That wasn't in the paper. This particular strain of Campylobacter is tetracycline resistant, and it was at the time that it was discovered in abortifacient products from sheep out west. How did it even get to Pennsylvania from Utah? Well, we're not sure. We have all kinds of ideas about how organisms move. But there was also no information about the people who were sick. Had they had antibiotic treatment before they were exposed to the raw milk? Well, we just don't know because the information wasn't there. And you'll find that's a common theme as we move through the rest of the talk. Oh, sorry. All right, one more thing about human disease that really spoke to me is a paper out of Denmark that looked at retrospectively about 5,000 people, I believe, as I recall. And the take-home message from this particular study was that people who were treated for Campylobacter infections, if they had taken fluoroquinolones within the 12 months prior to their getting Campylobacteriosis, they could see from these data that they were 2.4 times more likely to have contracted Campylobacter with that antibiotic exposure history. In addition, they were almost 4 times as likely to develop a fluoroquinolone-resistant Campylobacter infection. So as a person taking personal responsibility for my health, that spoke to me in that, oh, holy cow, if I'm asking my doctor inappropriately for antibiotics, I'm the one that's going to potentially suffer in the end, right? And as a healthcare provider, whether it's a veterinarian for pet animals or farm animals or a physician treating human patients, I think when I went through vet school, I don't know, 27, 28 years ago now, I really kind of came away from vet school with the feeling that there wasn't a downside to giving antibiotics. It was kind of that thing that you could do when you didn't know what else to do that would do no harm. In fact, no animal should ever die without the benefit of antibiotics and steroids. Right? I mean, that's what we thought. And I think now, as we learn more about the microbiome and the microorganisms that live in the intestinal tract of both animals and humans, we're finding that giving antibiotics is not something that does no harm. It has consequences. It changes the microflora. And in this particular case, it makes people more susceptible to developing Campylobacter. So some of the basic conclusions that we made from our study was that we certainly know from the literature now that on-farm antibiotic treatments will increase the colonization of animals with antibiotic-resistant Campylobacter. I don't think that that's really something that's in dispute. It's just basic biology. It's just going to happen. We're never going to fully get rid of drug resistance because bacteria are going to find a way, right? Somebody, at least one in the population, is going to figure out a way to survive. And we also found that antibiotic-resistant Campylobacter can be transmitted to humans from raw animal products. I don't think that's a surprise to anybody. It certainly makes us think about how food is handled before we eat it. And certainly some people in the room are probably involved in public health policy. And what does it mean that people can buy or purchase or get products that are not as safe as we know that we can make them and may not be recommended for them to consume, especially high-risk populations like young children and the elderly. And the current literature that we looked at is inadequate. It's not possible to make a direct connection between the antibiotics given to the farm animals and the drug resistance in humans. In fact, there's a paper out of Scotland, I think it was, it's related not to Campylobacter but Salmonella DT104, that showed that the drug resistance that develops can develop in parallel. In other words, the bacteria in people can develop resistance. The bacteria in animals can develop resistance. The bacteria only know how to do a certain number of things to respond to their environment. And so it actually makes sense, and they were able to show that with DT104, they had populations that were what we would call evolving in parallel. So the bacteria were evolving and developing drug resistance in the people very similar to how they were doing it in animals. But it wasn't because the bacteria were being passed back and forth from the people to the animals and the animals to the people. It was just the biology of the organisms evolving forward in time. And that's something where if I think about the antibiotic question in those terms, it makes me come from a place of it's not about blaming other people. It shouldn't be about the human healthcare industry blaming the agricultural or veterinary industries or vice versa. This just happens. Biology happens regardless of which setting it's in. And we all have to think about how we're going to play our part in in preventing it from being completely out of control. So the knowledge gaps that we recognized during the study were that most of the studies focused on 1 to 2 steps of the food production pathway. Trying to get these to come up. So the studies typically were either going to be farm-based, they were food processing based. Some had these 2 steps involved in the same papers. And then some of the other studies were just about retail products from grocery stores, and the meat that was in the grocery store was tested. There were very few of the articles that described the antibiotic use on the farm, so we weren't able to determine in most cases what drug, what dose, what route was it given, what was the duration of the treatment of the antibiotic. All information that you would really need to know to be able to compare studies and to make conclusions about best practices. So research in the future, we have a couple of suggestions. One thing is that it's incredibly difficult to compare these papers, in part because the methodology is so different. Everybody collected their fecal samples or handled them slightly differently. The antibiotic resistance was tested differently. This is just an example of the different tests that we came across that were all included in the literature during the time we looked at. There's the old traditional disc diffusion, which is not used so much anymore, but it's the basis of the E-test. And then over the course of the years that we were looking at, we had some data that was in E-test, we had some data that was broth microdilution, and the break points in terms of what numbers determined that there was resistance were different for the different tests. The break points evolved over time, and so it's incredibly difficult without some kind of national standardization for all of us to feel like we're speaking the same language, and that when I say that Campylobacter is resistant, that you guys would also recognize what level is that? Yes, I actually know what that definition is. Also, determining gold standards for genetic analysis. There are different levels of testing that give you different levels of specificity. And there were papers that we found where it was really a challenge to try to see through some of the conclusions that were made. We really felt like the testing that had been done was not adequate to support the conclusions, in part because some of the genetic testing is kind of broad and it gives you family relationships, but it doesn't tell you specifically that this isolate is exactly the same one that came from this scenario. And in order to do that, some of the newer technology and maybe down the road whole genome sequencing of these isolates will be available so that direct comparisons can be made and there's less confusion about the genetic analysis and what it means. There needs to be transparency about the use of farm antibiotics, as I mentioned earlier, and there also needs to be more details about the antibiotics that the people who got sick had been on prior to their getting sick. We see now that that's a very important part of the picture. And then finally, to determine appropriate metrics for public policy development, we don't need to act just to act. We need to act because we have rational reasons to act, and we need to recognize that everything we either add into the system or take away from the system is going to have some kind of downstream effect, and we may not be able to predict exactly what that is when we institute the change. So we need to be thoughtful and recognize that metrics are going to be a really difficult thing to make decisions about, and that needs to be done very thoughtfully. And then finally, I wanted to mention that I mentioned we were doing a study in parallel with Salmonella, and there wasn't time to discuss both of those today, but that paper has just been typeset and formatted, and it is on the website of Critical Reviews in Food Science and Nutrition and is available as well. The findings were very, very similar between the 2 studies.
Describe the sequence of events that happen when a person seeks medical care for GI distress. What does the clinician consider? How are antibiotic use decisions made? And what follow-up is there? Culture. What does a cure look like? Less days of diarrhea, medicine and reduction in fever, etc.
Oh boy. Somebody thought I went to medical school. first disclaimer, I'm not a doctor, but Cassie is a doctor on our team. And in our discussions with Cassie, it sounds like it's a lot like veterinary practice, right? If you're a general practitioner and a person comes in and they've got diarrhea, some of it's going to depend on what the signs are. Is it bloody? Is it non-bloody? What's the frequency? Are they dehydrated or not dehydrated? You're going to make decisions about supportive care first and foremost. The decisions about whether antibiotics are administered or not become, I think, related to the risk category that the person is in. Again, is it a young child? Is it an older person? Is it somebody who's immune compromised and there are concerns about the disease potentially actually leaving the GI tract and becoming systemic in some way? Typically, people recover from Campylobacter infections without needing antibiotics, and that's important to note as well. So it's typically going to be people that have had the diarrhea for a prolonged period of time and are not responding to supportive care or that have a risk factor that are going to receive antibiotics. Those are also the types of patients that typically would get a culture, but I think most doctors will admit to you that not everybody gets a culture. It really depends on the scenario, I think. And what, in terms of follow-up, the end of the course of the disease is when the diarrhea stops. For the patient, that's the end of the disease. Is there a follow-up culture that's done later? I don't have any idea, and if there's a physician in the room that normally treats Campylobacter infections, I would welcome your answering that question.
And the next question we often hear is increased antibiotic resistance. How is that measured or defined?
So in the study that we did, when we were looking at is antibiotic resistance increased, one place that you can look at those type of data is with the NARMS collection of information. So you can look at, for instance, rates of antibiotic resistance that's been collected from retail meat samples. You can look at it for isolates of bacteria that have been collected from people who were ill. And you can also look at it for animals and samples that were collected at the slaughterhouses. And so what you're looking at over time, to me, trends are really important. Instead of looking at absolute numbers are typically snapshots of today at this time, at this moment. Trends are looking at multiple years over time. There's some beautiful graphs of NARMS data that are publicly available where you can see what's happened over a number of years. And the concerns about particularly fluoroquinolone resistance related to Campylobacter is that there is a slow but increasing trend over the last decade of increasing percentages of Campylobacter that are grown from samples that come from food or from humans or from animals that show the resistance traits to the antibiotics.